Hi, my name is Steve Sutton. This video is produced by AIS Training Center to help you determine if you need to take a battery out of service and have it recycled or put it back into service and have it reused. Now, first, let's talk a little bit about the science of what goes on inside the battery and checking something called specific gravity. Specific gravity is measuring the density of a liquid compared to water. Now, water has a specific gravity of 1, or when you write it out, it looks like this. It's actually 1,000 if you were to actually say it, usually. It is a specific gravity of 1.000. A fully charged battery has a specific gravity of about 1,300. A lot of your books will tell you, or a lot of your literature, battery people will say 1285. Now, notice what I said. I said 1285 when actually it's 1.285. That is true. The specific gravity of this liquid, measuring it at this 1285 or 1.285, is 28.5% or a little heavier than water. But when we talk about specific gravities, we leave the decimal out and we say it has a specific gravity of 1100 or 1150 or 1200. Your fair range, your fair charged battery is going to be about in this range. Your well charged, your good charged batteries are up in this range, and your poorly charged or discharged batteries are going to be down in this range. And it will say that on your hydrometer when you go to measure it. Now, keep in mind, water coming out of the tap, it has very little, if any, charge. So what does that tell you? If your specific gravity in your battery tests way down low, your battery is discharged. The closer it is to one, or water, the more discharged it is. Therefore, the higher the number is, the better charged that battery is, or that cell. Now remember, we're checking one cell at a time. Okay, now let's talk a little about the tooling. First, what tool do we use to measure specific gravity? This is called a hydrometer. It's a simple type, it's just a float type. You can get different types at an automotive store off the tool truck, has little balls in it and floats, discs if you will, that float up and down. This one happens to be just a basic float type. It's numbered from water, has a scale that goes all the way up to 1,300, much like this scale right here. The higher the float goes, the higher the specific gravity. We'll get into this a little more when we check specific gravity. Another kind of tool to use to check specific gravity is called a refractometer. You open up the lens, you take a little sample of electrolyte, you put it on the lens, you carefully close it. Do not slam it because it'll splatter all over the place. And you look through the eyepiece, and basically what you're looking at is a scale. This one is made for antifreeze, for checking freeze protection, and for checking specific gravity of electrolyte or battery electrolyte. So on the right-hand side is a scale for freeze point. The left-hand side is a scale for specific gravity. You are not concerned about the freeze point of your battery electrolyte. You are concerned about the charge or the specific gravity. And we'll get into this a little bit more when we check specific gravity. Another tool to check when we go to load test the battery is a carbon pile load tester. You have a red lead for the positive side, you have a black lead for the negative post of the battery. You hook those up. On this side you have a voltmeter, nothing more than a voltmeter on the right, and a amp meter on the left. When you hook it up, you'll see a certain amount of volts, whatever volts is in your battery, how many volts it is carrying at that point. You should see 0 because your knob is all the way backed off. I'll get into more of that when we go to check it out. And you're going to crank the knob down to increase the amount of amperage going through the load tester. Now, how this works, inside the battery, inside the load tester, there's a series of carbon discs. And when the load is backed out, that is, the knob is all the way backed out, there's basically gaps between the carbon discs. It is not creating a circuit. As you load the tester down, you are squeezing those carbon piles, those carbon discs together, creating a better and better circuit, creating more flow to go through the load meter. That's how you are adjusting the amount of current to go through your load meter and load testing your batteries. More on this in a little bit. Another tool for checking the state of charge of your battery is this handy tool. This head happens to be a Snap-on. You can get them off the tool truck. You get them at an all parts store. You hook these up. It's powered from the battery that you're using, so there's no batteries in it. There's no on or off button. And when you hook it up, it'll tell you your voltage of the battery, and then when you test it, it'll tell you your state of charge of the battery in a percentage. More on this when we go to get to that part. Okay, we've talked about specific gravity and what specific gravity is, how we measure it. We've talked about the tools we use to measure specific gravity and some of the tooling you can use to load test the battery. Let's talk a little bit about battery sizing first. Just some simple nuts and bolts, nothing really complicated here. First of all, 12-volt battery versus 6-volt battery. Each cell in the battery produces about 2 volts. 2 to 2.2 volts is where they produce their standard voltages. So you count the cells. I have 6 cells on this battery. 2 times 6 is 12. This is a 12-volt battery. If the cell produces each produce 2.2, multiply that by 6, it gives me 13.2 volts. It's still a 12-volt battery, and it is entirely normal for a 12-volt battery to produce a little bit more than 12 volts. That's entirely normal. In fact, it's probably not normal or a bad thing if it's producing anything less than 12 or at 12. Now this battery, I only have 2 caps, but if I were to remove one of the caps, I will find underneath I have 3 cells under each cap. 2, 4, 6, 8, 10, 12, 12-volt battery. A 6-volt battery, 2, 4, 6 volts, has 3 cells. You hook 2 6-volt batteries in series, you get 12 volts. So here in front of me I have 3 different 12-volt batteries. Another thing while we're talking about the cells and opening up the batteries is if you have a maintenance-free battery, you can usually tell by the size of it that it's 12 volt, or you kind of got to look at the structure of the battery itself to tell that it has 6 cells in it. But you do not remove or to attempt to disassemble a maintenance-free battery for testing whatsoever. We'll talk about that more a little bit too. I can tell you, this one is a 1,000 cold cranking amp battery. I can tell because the sticker says 1,000 cold cranking amp. This battery right here, sticker also says CCA 1000. This is a 1,000 cold cranking amp battery. This is a 1,000, this is a 1,000, and there's an obvious size difference between the 2 batteries. You cannot tell the amount of cold cranking amperage rating of the battery by looking at the physical size. Let's go to this battery. 2 batteries of the same physical size. The top posts are the same basic arrangement. They're both 12-volt batteries. From a distance, they're the same size, physical size. This one is 1,000 cold cranking amp rating. This one is 625. So this one is actually 5/8 the size, or 5/8 the amount of cold cranking amperage as this one is. Same physical size. 3 different batteries, 2 different sizes here, both 1,000s. Same size, one's 1,000, the other one's 625. You need to know the cold cranking amperage rating of your battery when you go to load test it. That's very important because the way you judge your load test if it passes or not. So you need to know the cold cranking amperage of your battery and the amount of voltage in your battery. In front of me here I have my PPE, some of my PPE. I have rubber gloves. It's a good idea to hang on to those when they're on the batteries. I have safety glasses. Some facilities may require goggles or a full face shield for your overall best protection. Today I'll be using safety glasses with side shields. I have a rubber apron on to protect me against splashes also. This is probably the best suited you could be. From AIS Training Center, I'm Steve Sutton.
And I'm Joe Thompson.
Work smart
and work safe.